So we're back on the slide that I accidentally flipped to before. And what this shows is the same thing I was talking about on the document camera, which is that these normal curves can have different means and standard deviations. So the mean tells you what's the most likely value, where's the center of that curve going to be, and it can fall in different parts on the x-axis. The standard deviation tells you how narrow or how wide the curve is. So in other words, how spread out are the probabilities around that mean. And when you have a low standard deviation, it tells you that you're most likely to get values that are close to the mean. If you have a wide standard deviation, it tells you that you're more likely to get values that are farther away from the mean than you would if it were a smaller standard deviation. And it's shown graphically here. So I already mentioned the idea of area under the curve, but now we're going to dig into it a little bit more. And as I said before, the area under the curve in a normal distribution always equals 1. So again, I think it's helpful to think of it as a shape. It's a bell shape, and the area of that shape is always equal to 1. This is important because probability distributions, and especially probability distributions like this, have a really important quality. That quality is that the proportion of outcomes that fall between two values on the distribution are equal to the probability of an outcome between those values. And in other words, the area under the curve in between two values is equal to the probability of getting an outcome in between those two values. And when it comes to when it comes to normal distributions in particular, the distribution of these probabilities follows a really consistent rule. So I'm going to just briefly talk through what this rule is first, then I'm going to go over to the document camera and back up a little bit on all these concepts and talk about area under the curve as probability, as well as go through this rule again. But what the 68, 95, 99, 7 rule tells you, snappily, right, very catchy name there, but what it tells you is the area under the curve that falls in between 1 standard deviation, 2 standard deviations, and 3 standard deviations away from the mean. So this is a nice graphic here there that shows a normal curve with the mean in the center, and then lines going out for each jump in standard deviations away from the mean. And what this tells you is that for any normal curve, no matter what your mean and standard deviation are, 68% of the area under the curve always falls within 1 standard deviation of the mean, meaning that there's always a 68% chance that you're going to have an outcome that's within 1 standard deviation of the mean. Looking at 2 standard deviations from the mean, 95% of the area under the curve always falls between 2 standard deviations surrounding the mean. And this means that you always have a 95% chance of getting an outcome that's within 2 standard deviations of the mean. Again, no matter what your mean and standard deviation are. And finally, for 3 standard deviations within the mean, 99.7% of the area under the curve, so almost 100%, but not quite, 99.7% of the area under the curve falls within 3 standard deviations of the mean, meaning that for any normally distributed variable, you have a 99.7% chance of getting an outcome that's within 3 standard deviations of the mean. So as I said before, I'm now going to hop over to the document camera and talk about this with some more concrete examples.